Okay, IM1 people, this is lesson 1.1, solving equations. Our objective is that you will be able to solve one-step equations and multi-step equations. You will also be able to complete tables given to variables in a rule. So, the big thing is we're talking about equations now. An equation is a statement that the values of two expressions are equal. So, big thing there, we talked about that before. We have an equal sign now. When we talk about solving equations, so to solve an equation, that means to get the variable by itself. And we can do that by using inverse operations. That's these here in the table. And we're going to use them to undo what is happening to the variable. This question here is something you should ask yourself every time you see an equation. What is happening to the variable? For example, and we'll get to example 1 in a moment. What's happening to the variable x? Well, it's being multiplied by 3. So whenever you see something like that, in this case we're multiplying by 3, the inverse operation is division. So we're going to divide by 3 in example 1 to undo multiplying by 3. In the same way, if you see addition, you undo that with subtraction, or each of these here. I do want to say you'll probably just see these first 4 in IM1. When you see exponents, and this really should say an exponent of 2, you can square root to undo it, but when you do that, you are assuming that your variable takes on a positive value. But don't worry about that too much right now. You'll see that more later. I have another note here. An equation is like a balanced scale. So if you've ever seen one of those scales with like something in the middle, and there's like a bar there, and it's got like one side to hold some weight and another side to hold some weight. And if both sides weigh the same, then the scale is balanced. So for example, if we have 3x, maybe the equal sign is the middle of the scale there. Let's say it equals 6. Can you tell me what x equals? 3 times what would give you 6? Well, hopefully you recognize that x should be 2. But the idea here is that, I'm going to highlight it because this is also very important. If you change one side of the scale, then you need to make the same change to the other side in order to keep the scale balanced. So an example of what not to do would be if I just divide this left side by 3 to get x by itself. 3x divided by 3 is x. But if I just say that equals 6, then what I did was I took weight off of the left side and not the right. Oh, let's make that more of a straight line. So then we'd have just x here, but the 6 would be too heavy now. You didn't keep the equation balanced. So that's not really true. You can draw a little sad face. Don't do that. Instead, if you're going to divide the left side by 3 to get x, then you need to do the same thing to the right side. So what's 6 divided by 3? It's 2. And by doing that, you have kept your scale balanced. We have x and 2. And that's good. We want to do that. So keep your scale balanced by doing the same thing to both the left and the right side of the equal sign. Let's try that in example 1 here. So what's happening to the variable? We're multiplying by 3. So let's divide both sides by 3. I'm going to zoom in a little bit. That looks a little small. And if we divide both sides by 3, 3 divided by 3 is just 1. 9 divided by 3 is 3. Notice I didn't write a 1 here. You can if you want, but 1x is the same as x. All right. Example number 2. What's happening to our variable x? I see some addition. So we are adding 1.6 to the variable. The opposite of, or the inverse of addition is subtraction. Now, if you look at the expression on the left side of the equal sign, in our last lesson, we combined like terms. So we're going to do the same thing here. There's only one x term, but there are 2 terms with no variable. Those are like terms, and when you combine them, you get 0. You don't need to write x plus 0, because x plus 0 is just x. We can combine our like terms on the right side of the equal sign. So this expression here, 10 minus 1.6 is 8.4. All right. I want you to try practice problem 1 and practice problem 2 on your own, and then come back and check your work. Okay, so here's practice problem 1. The inverse of dividing by 4.6 is multiplying by 4.6, and we'll get C by itself. 5 times 4.6. You're allowed to use a calculator if you want. You'll get 23. Problem number 2. There is a fact in math that I want you to know. If you don't remember it, that's okay. But if we multiply any number by its reciprocal, or what we call its multiplicative inverse, we get 1. So if you were to flip 1/5, you get 5 over 1, which is just 5. And you can use that to say that, well, if I multiply both sides by 5, I will get 1v, or just v, and we get 150. If you don't want to use that trick, you can still say, well, the v is being multiplied by a number, and that number is 1/5. So if I do the inverse operation, I divide by that same number, and 1/5 divided by itself is still going to be v. Now keep in mind, when you simplify the expression on the right side, dividing by a fraction is the same as multiplying by the multiplicative inverse. So 30 times 5 over 1 is just 30 times 5, which would be 150. All right. Now, these ones are called one-step equations, the ones we just talked about, because the variable is just on one side. We can just do the inverse, and then we get the variable by itself in one step. But if the variable's on both sides, like in number 1, we have an r on the left side expression, and we have an r on the right expression. This is going to have more than one step, and that's okay. So in number 1 there, what I recommend you do, actually I'm getting ahead of myself, sorry. I have a table here. This is the order of operations in reverse. If you like to say it's PEMDAS, that's fine. But to undo that, we're actually going to subtract or add first until we get the variable on one side. And so that's what this step that I wrote in blue is there for. Since I have a 6r on the left and a 7r on the right, I need to do the inverse operation to make sure that the r disappears on one side. I chose to subtract 6r from the left side because 6r minus 6r is going to be 0. And when I do that, there's no more r on the left side. I still need to combine my like terms on the right expression. So 7r minus 6r is just 1r, or r. Now, this expression here, this equation here, excuse me, is like we saw above. This is now a one-step equation. What's happening to r? What's happening to the variable? We need to undo adding 13. So we subtract 13 and combine our like terms. And we have r by itself, so we have successfully solved the equation for r. Here's a different way to show your work. As you get more practice, honestly, I'd prefer you do it this way, just one step at a time first. But you could do the same thing to both sides. You could subtract 6r and 13 from the left side as long as you do the same thing to the right side. And then it just shortens the amount of work you have to do. All right, let's do number 2. Now, again, in number 2, we have a variable x on the left and the right expression. So you could cancel out the x on the left or the right. I chose to cancel out the x on the left. So I see a minus 4r. So I'm going to add 4x. So those, when you combine your like terms, will just be 0x, which is 0. And we have 13. But we have to add 4x on the right side as well. So there's like an invisible 1 here. So negative 1x plus 4x is going to be 3x. And then we still need to get x by itself. Before we take care of the dividing by 3, because that's going to undo multiplying, we need to take care of the addition or subtraction first. That's what this table here is talking about. So I want you to get rid of that plus 1 first. So we'll subtract 1. And now there's no more addition or subtraction to take care of. It's just 3 times x. So to undo what's happening to the variable, we can now address the multiplying by 3 by dividing by 3. Make sure you do it to both sides to keep the equation balanced, and you get x is 4. All right. Try number 3 and number 4 on your own, and then come back and check your work. Before you do, though, I'm going to give you a hint. You are always allowed to combine like terms before you start adding or subtracting to both sides of the equal sign. If I were you, I would combine your like terms on number 3 before you add or subtract. Okay. Combining our like terms, we get negative 10x, and then we can add 8x to both sides. That will make the x term disappear on the right side. If you want to do that in one step first, you can. I chose to do both in the same step. I also subtracted 2 from both sides, and that will get rid of the constant on the left. So now, after combining like terms, we just have a term with x in it on the left, and we have a term that's a constant on the right side of the equation. What's happening to x? Well, it's being multiplied by negative 2. So we need to do the inverse of that, divide by negative 2, and we should be left with x equals 5. Here's number 4. Check your work on 4, and go ahead and write it in your notes. We should get x equals 4. All right. You might see parentheses inside your equation, so let's do number 5 together. My recommendation is that you distribute. We talked about the distributive property in our previous notes. When we distribute that 4 to the 2 terms in parentheses, we'll get 4 times 1 is 4, and 4 times 5n is 20n. Combine your like terms, and then we have an equation just like we saw above. There is a variable on both sides, so we could subtract 12n from both sides, or we could add 6n to both sides. In this case, I added 6n, and I also subtracted 4. And that way, we have the n term just on the left side and the constant term on the right. Divide both sides by 18 to get n by itself, and n should be negative 1. Here's number 6. Again, distribute to get rid of those parentheses, combine your like terms, and then we need to get the variable n just on one side. So if we add 14n, that'll cancel out with this red one here. And if we add 20, then this on the left side, this plus 20 will cancel out this minus 20. We'll be left with 8n on the left, 24 on the right. Divide both sides by 8, and you'll get n equals 3. All right, 7 and 8, I want you to do on your own. Come back and check your work. There's number 7, and there's number 8. Pause the video if you need to, write these down, or change what you did if you need to. All right, solving equations with decimals and fractions. These ones are really the same as we did above, except now you're working with decimals. You can do it by hand and just show scratch work on the side, or you're welcome to use a calculator. So for number 9, distribute, combine your like terms. We need to add or subtract this constant term, so we're going to make sure that we get an f term, a term with a variable by itself, and the constant on the right, and then divide to really get the variable by itself without a coefficient. So f should be this weird fraction. That's okay. If you didn't do fractions, you might have done decimals, and it's approximately 0.657. All right, number 10. We don't have any parentheses this time, so we can just combine our like terms. And then before we address the coefficient of 10, we need to add or subtract to get rid of the minus 8. So we're going to add 8 to both sides. Now we have the term with the variable on the left, the constant on the right. Divide by the coefficient, and now we have the variable h by itself. All right. Try number 11 and 12 on your own. Here's 11. I would encourage you to try to keep it as fractions if possible. When you get your fraction to 25.5 over 3.5, remember if you can multiply by like 2 over 2, and that will give you your fraction where the numerator and denominator are integers. Or if you did a decimal, it should be about 7.28 or 9. Number 12 should get something like this. All right. I want to talk about 13 because 13 is a little different. We have a fraction bar here. So we are actually going to multiply both sides of the equation by the denominator because it's like there's parentheses here. And that will get us the numerator by itself, k plus 12. And when we multiply the other side, it'll get negative 174. Subtract 12 from both sides to solve for k. Let's see. You know what? 13 was a lot like 15, so try 15 on your own, and then come back and check your work. Here we go. And then, you know what? Try these two on your own as well. And if you have any questions, you can always ask me at the end of the video or in class next time I see you. There you go. All right, this last part, we have a word problem. And for now, I just want to have you do two things. Every time you see a word problem, you need to underline the important information and you need to circle the question. So when it says, suppose the length of a rectangle is 2x plus 1 and the width is 3x minus 2, find the value of x if the perimeter is equal to 38 inches. So it gave us three pieces of information. It told us the length, underline that. It told us the width, underline that. And it told us the perimeter, underline that. In this case, it's not really phrased as a question, but what we are told or asked to find is the value of x. It's really important you circle the question so that you can look back when you think you have your answer and double check that you answered the question. All right, another thing you should do, I drew it over here. If you can, it's a good idea to draw a picture. So it told us that, you know what, I might just draw it down here instead. Here's our rectangle. It told us we have a rectangle. It also told us the length of the rectangle is 2x plus 1. And remember, for rectangles, that means this is also 2x plus 1. And the width is 3x minus 2. But that means it's 3x minus 2 over there as well. All right. If you remember what the perimeter is, that's when you add up all the sides, right? So if the perimeter is 38, that means this side plus this side plus this side plus this side is 38. And that's what I wrote here. After that, you should combine your like terms. 2x plus 2x plus 3x plus 3x. Oof, that's 10x. And then 1 plus 1 minus 2 minus 2 is going to end up being negative 2. If you can get to this part, you've done the hardest part of the word problem, because now this looks like one of the nicer problems that we've done in these notes. So solve your equation for x, and we get a value for x. The last step, take your answer and double check, did you answer the question? In this case, we did. We found the value of x. But the reason we circle the question is because I could easily make this a much harder question by saying, hey, what's the length? And if you tell me, oh, 4, well, you're right that x is 4, but that's not the length. The length is, what is that, 2x plus 1? So you'd have to do some more work after that. Anyway, that's the end of 1.1. As always, ask a question at the end of the video, and I'll see you all in class.